right. Ladies and gentlemen, it is Wednesday, February 21st. We are back for another daily episode of Ask That. And today I have with me Chase Aucoin. Chase, how are you doing, sir?
I mean, I'm doing fantastic. If I was any better, I'd probably be twins.
That's an awesome response to that. I like that. I might steal it.
Go for it.
So before we get started and we get cooking, introduce yourself. Tell us who you are, what you do, where you're from, anything you want.
Yeah, awesome. I'm Chase Q. Aucoin. I'm from Kansas City, Missouri. Currently freelance consultant. Been doing consulting for the last several years. I've helped Fortune 500 companies, Fortune 50 companies all over the United States and large organizations all over the world fix their software development lifecycle processes and help them put out better software faster, more securely, etc. I love what I do. I'm also a lover of statistics, lover of machine learning. I play music, and I'm really tall.
How tall?
6'8".
Holy cow, you're tall.
I'm a big guy. Yeah.
I am around the 6'3" mark, depending on if I want to stand up tall or not. And it is when I find people who are taller than me, even though my father is 6'6", when I find people taller than me, not only do I feel like I have found new creatures, it feels weird to like look up to somebody because there's not a lot of tall people.
So imagine that, and then like go up a level.
Right.
Whenever I run into people that are taller than me, I'm like, everything is wrong in the world right now. I don't understand any of this. I was in San Francisco last year, and I was staying at a hotel that was right by the Raiders camp.
Sure.
And I was in the elevator with like 5 guys who had at least 6 inches on me and about 200 pounds on me. And I was like, I don't know what this is. Is this life?
Yeah, I had been on a team where there was 3 of us, and we were all 6'3", 6'4", 6'5", and anytime we would go somewhere, people would just look and be like, "What just walked in the room? Like, why are you guys here?" And I don't consider myself tall, but when I see people who are taller than me, it is. I now have some empathy to everybody who's shorter.
Yes.
So. All the wrong that I have done over the years, I apologize to those who are shorter.
Vertically challenged is what they prefer.
There you go. So today we are talking about machine learning. I had asked everybody, what keeps them up at night, what they're passionate about. You had said machine learning. Let's dive into that, and let's start with, what does that even mean for those who may not know?
Yeah, so machine learning is basically getting machines to respond to data, right? So given some data, you want a machine to be able to come up with some outcome, right? And the idea is basically programming without programming. You're wanting the machine to learn how to get to the end result without you explicitly saying, this is how you do it, var equals blah, blah, right?
Okay.
And so that in a nutshell is what machine learning is. And then you hear the word AI a lot. AI is like an extension of that. AI is machine learning, but machine learning is not necessarily AI.
Okay. So let's now make that a bit more concrete. So what does that look like for somebody programming, and then we'll just kind of go from there.
Yeah, so for somebody programming it, there's a lot of different paths you can take. So Microsoft has some really great suites with their tool sets from Azure ML, their new library CNTK is what I think it's called. I could be and likely am very wrong about that. You've got TensorFlow. TensorFlow is the big one. TensorFlow is the one that like gets the most press. That's Google's suite for machine learning.
Okay.
And it's what they use internally. And so I tend to, in general, favor products that larger organizations are using and having a lot of success with, because I don't really want to have to reinvent the wheel. And like, well, I'm no Google, but if they're doing it and they're getting a lot of great results, that's probably good enough for me.
Yeah, totally. So are we talking about a library that it gets included? Are we talking a service that we then use? What's the my app to
Yeah,
consuming some machine learning?
that's a great question. So whenever we think about it, there's two parts to it. One is training, and then the other is delivery. So part one, I want to train a machine to be able to do some task. I want it to be able to classify an image and say, oh, this is a monkey and this is a hippopotamus, or whatever, right? Or I want it to be able to tell me something meaningful about the data that I'm giving it. So I have to teach it how to do that, right? So that's part one. Part two is delivering that out, right, as some type of service. And so there's a lot of different ways that you can do that. And depending on which product you're using, some provide options for both, for one, for, whatever.
Sure.
And so with Azure machine learning and now AWS machine learning and some of the other ones, you can kind of do all of that together. What I like about Azure machine learning, especially for the beginner, is they have a lot of recipes. So if you have an idea of what you want to do, you can go look at their recipes, and they have just a ton of recipes that are going to get you 90% of the way there, right?
Okay.
Without you having to put a lot of your own thought into it.
Okay.
Because a lot of times that, like, coming up with your own ideas, especially if you're brand new into it, just like anything else, right? You're not gonna, if you're brand new to programming, you're not gonna likely go out and write the next NuGet infrastructural thing, right?
Yep.
And so it's really handy from that part. And then the other thing is it's very visual. If you're better at, like, seeing how things are connected, Azure ML is great for that. By the way, I've got no affiliation. I'm not sponsored or anything. I just like their product.
No, nor are we. So the teaching part, so step one, if you will, is that I have to assume that's both a manual thing and a programmatic thing. Is that a good assumption?
That is a fair assumption. So the hardest part about training is figuring out what data you want to put in, right?
Okay.
It's just kind of it's like most things in life, garbage in, garbage out, right?
Sure.
And so the kind of one of the harder parts is, like, really drilling into what question you're wanting to answer. Now, what's neat is with some of the more modern techniques, the nature of the questions that we ask are rapidly changing. And so historically, whenever we've looked at machine learning, we've looked at it like looking for KPIs. So key performance indicators, for those not in the know. So whenever we think of it from everything that we've kind of done for the last, 15 years or so has been more in the realm of replacing what we do with business intelligence and trying to automatically create that business intelligence. But we're now rapidly getting into an area where we can ask more interesting questions. And I'll give you an example of that. So historically, let's say you are a company that sells things, and you know that you want to market out to people, and you want to make $2 million in the next quarter.
Sounds
and
great.
So, yeah, right. And so you might say, all right, well, I'm really smart. I've been doing this for a long time, and I know that our key demographic makes about $50,000 a year. And I have all this information about our customers, but I'm not sure and it's incomplete. I'm not sure which ones necessarily make 50,000 and which ones don't. Sure. I know some of them that do, some of them that don't, and et cetera. But now I want to try and figure it out. I don't want to guess which ones make 50,000, right? And those are the kinds of questions that we would historically ask. We'd try to fill in the blanks, right? And we'd say, okay, that makes $50,000 a year. But what's more compelling and what's more interesting that you can do now is, instead of saying questions like that, you can take your hubris out of it. You can say, you know what? I don't really know who's going to be the best person to sell to. It might be somebody that makes $20,000 a year. It might be somebody that makes more or less, or some third thing that has nothing to do with money at all.
Sure.
So instead, you can start asking questions like, I want to maximize how much money I make this year.
Sure.
And that is a vastly different question than we've been able to historically ask our machines. We've not really been able to ask computers to, like, hey, I just want to make more money. Like, go make more money.
So is this only an after the fact, or can we do this at runtime as well?
You can totally do this in runtime. And there's a lot of really cool things that have come up over the last few years that have their roots in the 70s, but have just made a lot of traction lately with the enormous amount of computing power that we have today. And so whenever we think about what happens in real time, generally this falls under a type of learning that's called reinforcement learning.
Okay.
And so the idea is just like you train a child, you just let it know if it's doing good or bad, right? You don't really and sometimes you may say go do this thing, but it's all about positive reinforcement or negative reinforcement, right?
Okay.
And so where that gets really cool, why my money for like long term, like where we're going with this is in reinforcement learning, is you can simplify questions a lot. Because really all you're letting it know is it doing better or worse? And it doesn't have to understand any of the mechanics of what's going on underneath. It doesn't have to know any of the parts of, even if it's complex things that are going on, it just has to know if it's doing better or worse. And so that is incredibly powerful. So whenever we think about self-driving cars, whenever we think about automated delivery drones, whenever we think about all of the various things that we can, really anything that we want to automate, right? That is where a lot of the strides are being made right now.
Interesting. Wow. So we have a time component to this. What happens? We're software developers, so what happens in the case that we were telling it wrong? How do we kind of delete that, roll that transaction back and go, okay, well, we've actually been lying to you now for 6 months.
Yeah.
The robots will run the earth.
And that's a very real thing that can happen. So have you played Universal Paperclips?
I have not.
Okay, so it's a simple, and I apologize because I'm about to wreck your workday. So just prepare for it. Go look up Universal Paperclips.
Going now.
It looks deceptively. It is a simple game. It's a very simple game. It's all like simple interface. It's incredibly fun, but basically you start out, you are an AI that makes paper clips, and I don't want to spoil it too much, but you take over the universe.
Okay.
And it's interesting from that thought exercise.
Okay. I will destroy my day. Well.
Yeah, and it will be the most pleasant day of destruction that you will have. So it's a great little game. But yeah, so there are certain. So all right, so back to your main point. Like how do you unwind it whenever you do it? There's a couple of different ways that we can do that. Whenever we put things out into a production environment, we can let it act like it is doing things, but not actually doing things. So similar to mocking, right?
Sure.
So we're letting it execute, and we're monitoring results on if it were to actually do that thing.
Okay.
But not actually letting it do it.
Okay.
And then we can let that happen for a long enough period that we say, you know what, we're pretty satisfied that this is doing what it should be doing.
Where's the it feels like there is this, feels like there's a big time component of knowing whether or not we actually we're doing right before we unleash the beasts.
That's where training comes in. So during your training, that's where your biggest time sink is. So organizations tend to, and this is if I can get anything out into the wild that is a great thing for people to know, it's this. If your organization is looking into doing machine learning to help its business, don't treat it like development, treat it like R&D, because it's R&D, right?
Okay.
You have to very much take the scientific approach, which may mean the problem that you're trying to solve, you may wind up first attempt, you're right there, get exactly what you want.
Sure.
But you may also find that okay, this is going to take a little time for me to figure out what data I really need to be putting in and how I need to be munging it together and all of that. And so I really encourage organizations that are interested in it, don't put in policies that whip your data scientists. Treat it like R&D. And if you do, you'll be a lot happier and you'll get better results. But if you try to treat it like development, because it takes a long time even just to do the training. So from test sample to test sample, depending on how complex the problem is that you're trying to solve, you may be looking at 20 to 40 hours of letting it run to even see if you have good results.
Sure. And so when we're talking training, we're talking training the machines
Yep.
and our algorithms. We're not training the people to do the thing.
Yep. Yep. That's correct.
So you mentioned data scientists. Like, what type of skills are we looking at? I mean, is this something that I need to be a scientist to start using,
No.
or can
the only
do it?
everybody can do it. The only science part about it is make a hypothesis, test it, verify it. Like that's the science part, really, right?
Okay.
And there's no dogma in science. It's have an idea, test it. It either works or it doesn't. And if it doesn't, create a new hypothesis, try it again, and just keep that process rolling. As far as who can get into it, man, it's for everybody. It's for absolutely everybody, young, old. I don't care how long you've been doing this, you can get into it. And that's what's great is especially in the last 5 years. Now, 10 years ago wouldn't have been the case. It was very niche. There was a lot of all of the information that was out there about it was really geared towards high-end collegiate mathematicians, and the tool sets were for people that spoke that language, for people that dealt in math and looked at things in that way. But now we've got so many. But that's no different than when we were looking at early processors, right? So now we have all of these rich, robust languages that are on top of these complex maths that are going on way, way down under the hood that you and I don't have to care about, right?
Right.
And we're seeing very similar to that over in the machine learning space, where now you don't have to be as knowledgeable, and there is so much free training. There's so many good videos. There's so much good, well-written articles these days that are for the layperson, that you don't have to have years of calculus and algebra and stuff. That stuff doesn't matter as much these days.
So I'm getting the sense that this is going to sound bad. Anybody can do it.
Yeah.
It's applicable to probably almost everything. Knowing where we're at. Is it something that we can easily bolt on to existing systems, or do I got to be on the latest thing to kind of take advantage of it?
Yeah, we can bolt it onto any systems. So what's great is really it's about ins and outs. If you can break down your problem into that, I've got these inputs and I want some kind of outputs, right? Okay. But I don't want to have to figure out how to get from A to B, right?
Sure.
That's where machine learning fits in, right?
Okay.
And so if you can kind of step back from the nuts and bolts of it a little bit and just look at it from that perspective, that it's just ins and outs, it's no different than working with a method. It's no different than working with a function, And so, yeah.
So then we mentioned AI kind of falls into this, or artificial intelligence seems to be kind of the sister of all of this. Where does AI then fall in?
So AI, as we think about it, so there's different forms of it. So generally, whenever we talk about AI, we are thinking about generalized AI. So general AI is machine learning that has gotten to a point to where it can start improving itself.
Okay. And
once we get to that point, it will do so exponentially, right? At a way faster clip than any human can do it.
Sure.
We're probably not terribly far off from that. We're a little ways off, but with some new architectures. So there's last year, DeepMind put out a paper on, and I'm going to get the name of it wrong, but neural computers, and basically it's a Turing complete neural network.
Okay.
So what's interesting about that is that they were able to feed in a lot of rich data that was disparate and didn't know about each other, and it was able to generate some really rich content about the two of them together. There's a whole paper about what they did in the London subway system with this, and I don't have the specifics just right on the top of my head.
Yeah, we'll link it in the notes.
Well, yeah, it's got some really interesting stuff in there. And so between that and some of the other things that we have going on, I think that so within the next 20 years, we're not going to have semi-truck drivers, right? within the next 50 years, we will probably not have manual farmers. Most manual labor jobs will probably go by the wayside.
Because of the vast amount of automation and the fact that we have machine learning and AI. I mean, that's a whole lot of things coming together, not just
Yep.
AI
Yep.
and MI.
So with the readily available access to robotics in a way that we've never really had before, like anybody can open up an Arduino and start doing hardware work today.
Sure.
Anybody can start doing machine learning today. Anybody can start doing automation today, and so with all of that, we've seen huge strides in all of those fields from people that didn't necessarily have a formal collegiate background coming in and bringing a wealth of new ideas and sharing those ideas with each other. And it's been expanding rapidly, and it will continue to expand rapidly.
Yeah, I was just about to ask, like, how do you know if AI or MI really fits into something that I should be doing?
That's a great question. A lot of that is going to be around, do you know the answer? If you already know the answer, like, should I X or Y? You just put it in, right? You don't need to have a machine figure that out for you, right?
Sure.
But if you don't know, that's where it fits in.
But is there a place that instead of me writing these answers all the time, I could start to use machine learning to really augment and AI to augment the stuff that we are creating? I
Yeah,
mean,
absolutely.
because in some regards, like we're teaching the machine learning to do these things. So rather than me like write out all the permutations of the thing I need for the screen, shouldn't I just teach the thing to do that for me?
And we're getting very close to that, in fact. So that particular type of machine learning is called a generative network. And
Okay.
so you see this a lot in more modern video games. There's the space game that uses that heavily, where it's got trillions of potential worlds that you can go to,
Okay.
and all of it's procedurally generated.
Okay.
They use a lot of AI in that. They use a lot of machine learning in that. They use a lot of machine learning in Fallout 4, and then we have some really interesting stuff right now where they have been able to train networks that so what they start with is real images of birds and then descriptors of those birds, yellow, black beak, just
Yeah.
text
Yeah.
that describes different features of the bird.
Gotcha.
And then they have a dueling network, one that's really good at guessing real images from fake images, and then another one that is really good at generating images. And they fight against each other. So one's trying to generate images that fools the other one
I
that's trying to get better and better at guessing real
Sure.
from fake.
Sure.
And eventually you reach convergence where the one that's generating images is generating images so convincingly that the other one can't tell the difference.
Gotcha.
And at that point, what's really cool is you can then just put in the text and say, I want a red bird with a blue background and all these things, and it will put a image that is net new, never existed before, but looks incredibly convincing.
That's a little bit scary in the world of hacking and everything that we have going on.
It is, and especially with like the incident with deep fakes over the last couple weeks. Since December. So we're only going to see more and more of that, and I think that's where our jobs as technologists is to try and get. It can be scary. It can be, but it doesn't have to be. And I think that's the thing that we can do as responsible technologists is get out there and really help people understand that this doesn't have to be a bad thing. Right. It's not a bad thing, in fact. Like what sucks is more where we're at with the society than the technology itself. It's awful that if I lose my job to a machine, I go, man, I've lost my job to a machine. I don't know what I'm going to do. As opposed to, awesome, a machine's doing my job.
Right.
I'm going to go do carpentry now.
Yeah. I mean, I've long said that, like, if we can use a machine to do a job, that lets you focus on something that's vastly more important.
Yeah. or
Um,
or at least more personally fulfilling, or
yeah,
et cetera.
absolutely. Yep. Especially if you're making money off that machine doing the thing for you, right? That's
Yeah.
just even better. So let's for a second let's talk about culture and internationalization. So it's easy. It's one thing to think of the Tesla that's self driving and learning, a stateside road. You had some other examples of teaching a thing to do a thing. How much of that really changes when we start to cross the pond and we think about other cultures and texts and languages that are right to left versus left to right? Does that just throw us all to the wayside and we start over,
No.
or
No, absolutely not. So what we have in those types of instances are networks that are called autoencoders, and so the best example of that is Google Translate.
okay?
So Google Translate is just a big neural network that can change any uh, one type of text into another type of text. Um,
Yep.
so um, that same type of process can be used for really anything if you want to convert from one thing into another thing.
Okay. Okay. Well, with that, I want to thank you for the
Absolutely.
work that you've done. Thank you for coming on here and putting yourself out in the community and speaking about that. Um, just from all of us to you, thank you for doing that.
Appreciate you.
With that being said, last question or set of questions, what would you leave behind? So knowing what you know today
Yeah.
and everything that you've done in development, thus far, or whatever life, it doesn't have to be just development. Like, what would be your kind of life tip or set of life tips to say, I wish I would have done this better, or this has really worked for me, whatever.
The biggest piece of advice that I give people. So I've had a very interesting life. I've died a couple times. I died when I was 16. I died when I was 30. I had my aortic root replaced at 16. I had my entire aorta replaced at 30.
Wow.
And that one was a very sudden thing, and it's amazing that I'm alive. Which, by the way, it's Marfan's Awareness Month. So if you have a child that has broad shoulders, bad eyes, very tall, pigeon chest or funnel chest, maybe go to the doctor, have them checked out and screened for Marfan's. Sorry, that was a quick plug there.
No, we will put that in the show notes.
The my biggest piece of advice is this: focus on what the next thing is. Right? Don't worry about what your long term goal is. Have it in your head. Like, know that you want to get somewhere. I use the Super Bowl analogy. How do you win Super Bowls?
Well, it starts with a whole lot of money and buying a really good team.
You get more points than the other team, right?
Yeah,
That's
yeah,
that's how you win Super
yeah,
Bowls. Same way if you want to get to the Super Bowl, so you got to win playoffs, you got to win
yeah.
games, you got to all that to get to
Sure.
even get there, right? And so if you don't get there, if you don't get to the playoffs, if you don't win games, then none of that matters, right?
Yep,
The Super Bowl
yep,
doesn't matter. Um, and then to win games, you got to get first downs, right? If you don't
yep.
get your first downs, if you don't get that next step, getting field goals, getting points, winning the game, winning the series. None of that matters, right?
That's
If you don't
right.
get first downs.
That's
So
right.
doesn't matter what you do in life. Really try to get your first downs. Whatever is next. Don't put everything else out of your head. And sometimes that's really, really hard. But try your best to just put it out of your head. Focus on what's next.
I love that. Move the chains. Move the chains down the field. I love
Yep.
it. Chase, how can people find out more about you? Where can they go?
You can go on LinkedIn. You can check me out on Twitter at Chase Aucoin, Aucoin. You can also check out my new project that I've got coming up, the Microservice Manifesto. That's microservicemanifesto.com. And so that's trying to codify some of the big pillars around microservices and all that. And then, of course, LinkedIn and all the usual suspects. And yeah, reach out to me anytime. I'm passionate about answering questions, so you can ask me a question. I prefer it whenever you ask publicly so that everybody else can
All right.
learn as well. So ask me on Twitter if possible, but if it needs to be private, shoot me out on LinkedIn.
All right. Well, we will include all of that below or above, depending upon wherever this is at. And with
Awesome.
that, sir, thank you. I'm gonna go make some, I don't know, very smart bots try to do some that conference work, so I can do a little bit less.
Awesome, man.
All right.
Well, hey, have a great rest of your day.
Will do. You too.